Hi, this is Bradley Johnston, and I'm here presenting my CS312 Computer Vision and Computer Graphics final project. What I decided to go for was focusing on multilingual OCR, or optical character recognition. Now, just just a preface, what OCR is, it's optical character recognition, like I said, and it's a field of computer science in which you look for text in an image and can recognize it as that specific character. This is difficult because really converting from text to an image, that's plenty easy. You can convert to a JPEG or a PNG and you can manage that just fine. However, converting from a JPEG or a PNG to a string to characters, that is significantly more difficult. Now, there are ways to do it, and a common set that you can use is, or in Python specifically, is called tesseract. Now, my original problem that I wanted to solve was trying to decide which training dataset to use, because English text can't be interpreted by a Korean dataset, Korean can't be interpreted by an English dataset, and there are plenty of different datasets to use. My plan was to create an algorithm or a neural network that could look at the character or section of text and determine which training dataset to use. Now, there are a couple of different challenges with this, such as languages are hard. They're not consistent, they can be vertical, they can be horizontal, they could be backwards. There can be weird formatting, such as here, or shown here is a Korean um, participle with 3 different Korean characters. To read this, you read from the top left to the top right to the bottom, and then you can also move to the bottom left and to the bottom right. However, there are different forms of that, and I felt like that would be difficult to be able to determine which, or determine this as a single character or participle. And the other problem is that multiple alphabets can be used in a single language, such as Japanese, which uses, I believe, hiragana, a simple alphabet, katakana, a more complex alphabet, and kanji, which is very loosely just Chinese symbols. And this is or kanji is a very complicated alphabet. Now, just to reiterate, my plan was to create something to detect the language of some text, and to do that automatically. But someone beat me to it. There is a library that you can install for Python called langdetect that will just do that. Alright, new plan. Still working with optical character recognition because I think it's interesting. And on top of that, I wanted to work with some foreign languages because I had already put in plenty of research there. Now then, what are we going to do with this? Oh, I know. We're going to take a comic book or a manga that is in a foreign language, translate it, and determine how accurate the OCR is. Now, this gives us a few steps. First, we need to get OCR working, including the image processing and the image cleaning. Test multiple different methods of cleaning the images, and then convert the text. Then we also need to test the accuracy. So I went through with a couple of different image processing algorithms. We have our original image at the very top here, and it's important to note that all images used in OCR need to be in grayscale. If it is not grayscale, it can't determine what it is, so all of these images are converted to grayscale. Now then, we also use thresholding, which will essentially just make sure that each pixel isn't gray. It is either black or white. This will give us hard edges, and I just wanted to see if that would work. I also used Canny, which was more so an edge detection. Then I tried combining a couple things. I tried to dilate with a threshold. I tried to remove the noise and use a threshold. Some of these worked, but as you can see towards the bottom, you can't really understand what's going on there. So I ended up sticking with thresholding. Now, as you can see on the right side, we look at each character specifically, and we get a confidence of how certain we are that we have the character correct, as well as what we think the character is. And you'll notice right in the middle there, there's one with a confidence of 55. And this is one of those complicated kanji characters that I was talking about earlier. These are going to be much more difficult to translate just by the nature of them. But let's go ahead and see if we got it correct. The original text for this should have been, "This is Japanese text." I then took the string that the program gave us, threw it into Google Translate, and what we got is, "This is a Japanese text." Now then, this means that our OCR, our optical character recognition, worked extremely well. I am uncertain whether this is a problem with Google Translate in that it added the article a, or if this was a problem with the optical character recognition. Now then, I think this is a huge success, so I decided to take it into a more real-world scenario. Here we have a scene from a manga in Japanese. I put this through our optical character recognition, and let's focus on this top right section of text. We have the English version right here, and in it, it says, "I can't tell if he's assertive or if he's shy, but ... dot dot dot." Now then, let's go ahead and see what we get. Now, we have the English text on the left, and then we have the translated on the right. What we were able to grab is, "Are you aggressive?" Now then, this wasn't great. In the real world, or in our real world application, we kind of got the right idea. We got the, "I can't tell if he's assertive," but we then changed it to, "Are you aggressive?" It's along the same lines. I feel like this is a problem with Google Translate, as well as a problem with the optical character recognition. So there certainly are some more things that need to be done. Now then, this is a project that I want to keep working on, as I feel like there's a problem in this community, the manga and the comic community, that I can fix with this. It is common that there are comics or mangas that are left untranslated. And this could be solved by this one program that will read the manga, translate it, and then overlay the translated text onto the image, onto the original image, therefore overlaying the Japanese text with English, or overlaying the English text with Japanese. The current problems that are holding me back right now are with the OCR. I need to work with some more cleaning algorithms to try and see if I can get it working in the manga comic focused environment. I feel like the problems with having a lot of actual people um, or buildings or the setting of the graphic environment caused a problem. So finding a way to focus on these texts specifically, as well as the translation tools not currently being up to par. So if I were to go forward with this, I would first want to focus on getting the optical character recognition to work for our mangas and our comics specifically. And it's possible that if I am unable to get it to find sections of texts or the word bubbles or whatever, I might have it display an image to the user that the user can then click and drag to create sections that should be translated. The second problem of the translation, this is much more difficult and deserves to be a project all of its own. Now, I feel like I didn't do what I originally set out to do, largely because it had already been done. However, I feel like I certainly learned a lot with this. I was able to learn about specific methods used for Japanese text or Korean, um, and I found that not there's not a lot of documentation out there for Japanese optical character recognition that is in English. So I currently have the problem of needing this program to read the text, translate it, and overlay it in order to learn how to read the text so that I can then translate it and overlay it. So that was one of the problems that I had, but I feel like that I learned quite a bit, and I was very excited with this project, and I hope to continue going on with it.